Hey guys, how's it going? Welcome back. Anyway, today we're going to give you a little bit of a video on how to test your battery in your Estes we2012 and your SO31, just to check for proper actual voltage. Now the SO31 as well as the Estes we2012 both run 7.4 volt, should be 1100 milliamp batteries in them. Okay, now even though it says 7.4 volts, you actually do put out a little bit more power than that in order for the battery to be actually charged and usable. So if you're basically at 7 volts or below, if you're even below the 8 volt range on a fully charged battery, your battery could be starting to get weak, or you could just, you know, your batteries had the biscuit. But you should have just over 8 volts on a fully charged battery, and your battery theoretically should be still good. Okay, this is not a 100% test, but it gives you a really good idea of the condition your battery's in. So if you checked all over your entire helicopter, you found nothing, no reason or rhyme for it not lifting off, I would go to the battery and test the battery voltage, because even though your charger says your battery is fully charged, that may be a false charge, because you can still charge the battery fully and the charger will think it's fully charged and you still would have below 8 volts. So anyway, so here's how the test is going to go. You can either use the power leads or you can use the leads from your charger. It doesn't matter, but you're going to need a cheap testing meter or a testing meter, either way. The digital ones are the best because they give you the actual voltage reading more accurately and easier to understand than the old manual style. So what we're going to do here is we've got our positive and our negative. So I'm going to go off the charger connector and put my negative on my negative, positive to my positive, and I'm registering 8.14 volts. Now that's a fully charged battery that's in good condition for an SO31 or an Estes we2012. That is exactly what your voltage should read if your battery is in good shape. Now I know the battery is in good shape on this. My helicopter still flies, I still get great flight time, etc. Now there's also an assault helicopter out. It's a Cobra model, and this is actually the battery out of it, and it's the same thing. It's a 7.4 volt battery. Now this one hasn't been charged in months, and the helicopter, of course, no longer exists because I just didn't like it anymore, and I figured I'd strip it for parts. So anyway, now after studying for several months, I still have 8.12, about 8.11 to 8.12 volts, which is more than sufficient for getting that helicopter off the ground. So check your voltage readings. Another test we'll do is for the SO31G, a little addition to this one. Now the SO31G uses a 9.6 volt battery at 800 milliamps. This one has definitely been off the charger for a long time that it hasn't been used for. So a little trickier to test this one, but we should be able to get it in there. Okay, 10.14 volts for a 9.6 volt battery. That's still a very good battery. It's the proper voltage for fully charged. If you're reading a little bit higher than 10.14, that's fine. It's not a big deal. It's just the way the nature of batteries are as far as voltages go. So even though, yes, it's 9.6 volts, you have a 9.6 volt toy, the battery actually reads a little bit higher. Don't worry about it. That's normal operation of batteries. It's just the way they work. So that for sure is definitely still a really good battery. And this thing, like I said, it hasn't been charged in months. And that actually came out of my SO31G, this one here. So that's how you test them. Now this isn't a 100% test. This is telling you that your voltage is definitely good. It doesn't mean that your amperage is good. So this may or may not solve your issue. If your voltage is below 8 volts you may have a problem with liftoff, because that voltage is going to stay up there consistently for a couple of minutes while you're flying before your milliamps drop enough that you won't be able to fly. So when you start looking at an exhausted battery, we're going to do a test on that too for you, which will be a second segment to this video. What I'll do is I'll just exhaust a battery completely in one of my helicopters, so you'll actually see the helicopter in the video, and we'll go off the leads for the charger and show you what an exhausted battery actually reads at, so that you know the difference. Okay, so we'll be right back with that video segment on this one and show you how that reads. Hey guys, so here's our Estes we2012, aka the SO31. Now, what we're going to do is we're going to take a before check for the battery voltage, and then I'm going to run this battery just to the point where it can't get liftoff anymore. So we've got 8.09 volts, which is still lots to get this thing off the ground. And we're just going to lift it off the ground a little bit just so you can see. And then we're going to run the battery to the point where it can't get any lift off and show you approximately where the voltage is actually sitting with this machine. So let's power this up. I don't have a very big room, so I can't really just fly it all over the place. But I'll show you that it does have lift off with that voltage range. Okay, so we do have lift off. So we are going to just run this thing until it can't get off the ground. So I'll stop the video here and then I'll come back at that point, because it's going to take a lot longer to drain the voltage doing it this way, so the helicopter won't get off the ground than it would by flying it. So, and it's still pretty snowy outside and pretty cold, and I don't fly my helicopters in the winter after the last couple episodes. So we'll be right back. Okay guys, so we're back now, and we've exhausted this battery to the point where it ain't getting off the ground. So just to show you here, it's going to skate across the floor on me. Oh yeah, I'll just hold it in my hand, I guess. Hold it down with my foot maybe. Oh, that ain't gonna work. Okay. Let's try this another way. Okay. So there's definitely not enough here to get it off the ground. That's pretty much done. So let's check our voltage out. Let's see where we sit with our voltage now. And this will give you an idea what kind of juice is actually there with an exhausted battery. So again, we're going to go off the charger wires, a little easier to get to. And we've got 5.85 volts. So well under 8 volts. Now this is an exhausted battery that, you've done all your flying and hopefully landed safely, because at this point it'll pretty much drop almost like a stone. So that's going to be just showing you that voltage actually drops, because a lot of people used to think that, you know, voltage is always the same, your amperage, you know, is where it's at, and even in car batteries, you know, that's what we were taught years ago, and then of course that got just proven real quick, and voltage does actually drop as well as amperage. So 5 volts, you don't have a lot of amperage left, so out of a 1000 or 1100 milliamp battery, you know, you're going to get your 6 to 8 minute flight time, providing your voltage is up and good. It doesn't mean you have 1100 milliamps. If you have a really good battery like this one is, you'll easily get 8 to 10 minutes flight time without any kind of problem on a very low to no wind day, or flying inside, say, a gymnasium. Okay, you'll get your good flight time out of a really good battery. Your battery voltage will drop little by little as your amperage starts to lower in the battery, even though, you know, like I said, it's fully charged. You know, you should have the power there, but that's not always necessarily so. Your amperage over time does drop. So if your voltage is good, okay, bottom line, if your voltage is good, it's reading over 8 volts, but you're not getting off the ground, then you could have still not enough amperage. You could have 500, you can have 400 milliamps, and 400 milliamps should get you off the ground, but not if your motors are drawing all that at one shot. There may be not enough milliamps or amperage for your motors to be fed properly. So, you know, take a look at that. I mean, it's kind of a really messed up system as far as that goes. I've got helicopters that, you know, they're 3.7 volts. They run on, you know, 75 milliamps, right? But the batteries aren't drawing anywhere near that. Or sorry, the motors aren't drawing anywhere near that. Whereas this one, I mean, it draws some good amperage, which is why you need the 1100 milliamps. So, you know, but, so if your voltage checks out, everything else checks out, you know, you don't have any broken parts. We do have the SO31 repair solutions video you can check out too that I did, for all the things you need to check over. And if all that stuff passes, your battery passes the test. This took me 10 minutes to kill this by just holding the helicopter in my hand with full throttle. And you could feel it wanting to pull off the ground, right, or off my hand. And so there's a lot of RPM there. So if your RPMs are really low, you may not have enough milliamps to drive those motors. Even if your voltage is good, if you don't have the amperage, then your battery is basically toast, right? And that's how you got to look at it. So, because there's no other reason why, other than all the things that I give on the checklist to look at, why it wouldn't get off the ground. So, because I mean, you could have dinged up blades and still get off the ground, no problem. I've got helicopters that got severely dinged up blades, and they still fly perfect, they still get off the ground great, because everything else is good. I have nothing that's loose, I have nothing that's, you know, flopping around, no bad gears, etc., etc. You know, my battery is really good, it's still going to fly, you know. In the case of not being able to get liftoff at all, and everything on the checklist comes out perfect, except maybe your battery may be below 8.14 volts, maybe it's running at 7 volts. At 7 volts, it may not be enough at the voltage level to get this thing off the ground. So if it's running at 6 volts, it definitely doesn't have the voltage or the amperage to get off the ground. So, and like I said, that 8.14 volts, that'll last for a couple of minutes before it starts to drop down. You know, and as you've seen it, it's down to 5 volts now, and ain't no way it's getting off the ground. You know, so, and I still don't have 1100 milliamps left over either with that 5 volts. And even if I had the amperage, I don't have the voltage, because these motors require the 7.4 volts. You know, they'll still fly the helicopter while it's in the air at 7 volts. It'll do it probably at 6.5 volts. But then it's going to start dropping because I'm going to have to add more throttle to keep it up in the air. And that's the thing. I mean, this thing will take off at half throttle or just basically one little movement nick above half, it'll take off in the air, not a problem. So you know, with this kind of a helicopter, because of its size, its weight, you know, you're definitely at just above half to get off the ground. You're a couple notches up after that to get her nice and high up in the air, fly around, have some fun, because you're kicking in the third motor too for your tail rotor. That's going to draw more amperage too. So we've done the voltage test for you to show you the voltage before and after, what it should, how it's going to read. Definitely on the before side, properly charged battery should have at least that 8.1, 8.14 volts to be a good battery. And that would be also telling me that the amperage hopefully, or should be, good as well. But it's not, you know, a permanent, you know, physical law of rule that that's the way it actually works. Because like I said, you could still have, you know, half of one of your cells that are bummed. So now maybe you, instead of 1,000 or 1,100 milliamps, you might be down to 500 milliamps, but the motors want 600 or 700 milliamps. Well, guess what? You might not be getting off the ground. So that's the other thing to consider. So try a different battery. If everything else checks out, try a new battery that you know is a good brand new battery. It's reading the proper voltages, it's been charged properly, and you should have no problem. Now with the Estes helicopters too, the charger packs that come with them are garbage. Every single Estes helicopter I bought so far for this model, all the chargers have been bad. So I actually use a Cobra charger to charge my my Estes helicopters up with. Now you can get those from Cobra RC Toys. They're not that expensive and they work flawless. They charge properly, etc., etc. I've never had an issue with my Cobra charger yet. And I use it to charge all 4 of mine because I have 4 of these the same. So I know they're being properly charged. I've tried fixing the Estes chargers. I still have not figured out what the problem is because everything seems to check out. Resoldering the board doesn't work, so there must be something underlying within the board or something that's just an annoyance that I just can't seem to get those chargers to function properly again. So, you know, your Estes charger may be the problem, because if those 2 lights flash on it, that means a bad battery, you know. And I mean, how many of these show up, right? I've talked to a lot of people that have the same helicopter and they've all had the exact same problem with the charger. So they definitely got bum chargers all over Canada and the US with these helicopters. The helicopters are awesome, guys. They're worth the money. It's the chargers that suck. So you're going to have to get an aftermarket charger, you know, which is fine. They do work great. Like I said, the ones from Cobra for the SO31. Now there is the 31 and the 31G. The 31G is a 9.6 volt. So you got to make sure you order the charger for the SO31. And you'll get the correct charger for this helicopter. And that's all you need to do, you know, and you should be fine up and running. Because I've never even had a bum battery yet. I got one of these helicopters now. Just countless numbers of flights on the thing, and it's still going strong, you know. So the batteries are definitely not an issue, you know. So anyway, that's how you test them. That's how you check your voltages before and after to know what's going on. Other than that, I'm out of ideas, guys. So if you still don't have liftoff, I don't know what to tell you. You know, maybe check, make sure your blades are spinning the right direction too. You know, if you look at your blade spin, see if we can get this thing to fire again. No, she's had it. Okay, I'll get another one of my helicopters here. Like I said, I got a few of these things. Okay, let's swap this out. Turn this one off. Now this is our blade direction test here we're going to do for you. So you know which way the blades have to spin. Okay, so top blade goes this way. Bottom blade goes that way. Yep. So top is top blade is clockwise, your bottom blade runs counterclockwise. Now if you look at your blade direction for your blades being installed, top blades, this should be facing this way, this one across this way. Okay, your bottoms, they should be facing like so. Alright, as long as that's all fine, you should still be getting off the ground. As long as everything else is fine, you should still be getting off the ground, no excuse. Burnt out motors, that could happen. You know, if you've got bad motors, they won't get up to the proper RPM. So that, I guess, is going to be the very last idea here, is everything checks out mechanically, your battery checks out, and you're not getting enough RPMs for liftoff. It's got to be in the batteries. Or, sorry, in the motors. So, there you go. Anyways, hope you enjoyed the video. Thanks for watching. Feel free to leave your comments, and if you have any questions, feel free to ask. I play around with a lot of these RC helis, as you guys know, so, you know, if you have any questions, as long as I can answer it, I will. So, we'll see you on the next one.